This is the laptop that always makes me feel kind of stupid. Because normally, since I have this YouTube channel, I have the Max version, this is the M4 Max, and now I have the M5 Max, which is supposed to be the ridiculous one. And then I go back and test the Pro chip, open the same apps, do the same work, push it through the same nonsense, and I start having some very uncomfortable thoughts. So I decided to test everything, not just the synthetic benchmarks, real builds, real SSD transfers, real AI models, side by side. And what I found is that some of these results are embarrassingly close. Oh, what? Between these two, not that one. And some of them are not even in the same universe. Okay. Let's start with what you can actually see. By now, you've already seen all the specs of the whole M5 family, I'm sure. Plus, you can get this from the Apple website. But here's the speed run of all the important items that affect developers. 14-inch M5 base model. The M5s don't come any bigger. M5 Pro and M5 Max are in 16-inch because that's how I prefer it. I have more real estate for my code. Personal preference, you can argue me in the comments. Since I'm looking at performance, the key numbers are 10 CPU cores on the M5 versus 18 CPU cores on the Pro and the Max. These are just the models I have. There's other variations. 1 fan on the M5, 2 fans on the Pro and the Max. Now, the memory bandwidth that roughly doubles at each step. 153 gigabytes per second, 307 gigabytes per second, and 614 gigabytes per second. Although those are just theoretical numbers, and I'll show you the real numbers later. 2 things to flag before we start testing. The Pro and the Max get Thunderbolt 5, 3 of those. The M5, Thunderbolt 4, 2 times slower. And both the Pro and the Max support high power mode, and that lets you push the fans harder for sustained workloads. The M5, well, that one doesn't have that option. You only get the dial it down low power mode option, not push it harder like the M5 Pro and the M5 Max. Keep it in mind, it's going to come back later. Every time you clone a repository, install dependencies, or open a project, or download an AI model, that's your SSD it's hitting. And there are actually 3 different speed stories here depending on what you're doing. Oh. What? SSD speeds are much faster on the M5 Pro and the Max since Apple adopted PCIe Gen 5. And disk speed depends on the size of the drive. Higher capacity models have more NAND chips for parallel access. And they also have larger SLC caches. And you can see that here. My M5 Max has 4 terabytes, M5 Pro has 2 terabytes, and this one has 512 gigabytes. These are some crazy numbers. And even the slowest one here should be enough for most use cases. For reference, the M4 at 512 gigs did about 2,600 megabytes per second read. The M5 Max at 4 terabytes, 7,200. Now the M5 Pro and Max, 13,200, 13,500. And for write, 15,400 and 17,300. That's roughly double what the M4 Max did. That's PCIe Gen 5 at work. M5 is no slouch either. That's like 2.5 times faster than M4. But is that what real file operations look like? I copied a 4.5 gigabyte LLM file from one folder to another on the internal SSD. The M5, 2.1 gigabytes per second. The M5 Pro, 8.9, and the M5 Max, 10.4. Real numbers. And that confirms the synthetic story. PCIe Gen 5 on the Pro and Max is real, and you can see it in raw sequential copies. Then I copied the entire WebKit source tree, over 500,000 files, 43 gigabytes in tiny source code files. Can you imagine how long it took them to write that? And they didn't vibe code that. M5, 260 megabytes per second. M5 Pro, 276. M5 Max, 306. A little different, huh? But only an 18% spread between the M5 and the M5 Max. So for internal many file operations, all 3 machines handle metadata roughly about the same speed. The internal SSD controller isn't the differentiator here. So how fast can you move data to an external drive? This is about the Thunderbolt bus, not the internal SSD. I plugged identical Thunderbolt external SSDs into all 3 machines and copied the same 5 gigabyte model files. The M5 on Thunderbolt 4, about 1.4 gigabytes per second write, 3.9 read, and now we see a big difference. The M5 Pro on Thunderbolt 5, 3.4 write, 9.6 read, and the M5 Max, nearly 6 gigabytes per second write and almost 11 read. Clean scaling. Thunderbolt 4 caps the M5, and the Max's faster internal SSD controller gives it an edge over the Pro. A slight edge, even though they're both on Thunderbolt 5. Then I did the same thing with the 500,000 small files. The M5 and the M5 Pro, essentially identical. 67 to 69 megabytes per second write, nearly 10 minutes each. Thunderbolt 5 didn't help at all here. The bottleneck isn't the bus bandwidth, it's IOPS and file system metadata. The M5 Max, 5 times faster at 336 megabytes per second. That's the different storage controller doing its job. And that's what real dev workflows actually look like. Cloning a repo, copying node modules. Oh boy. So when somebody says my SSD benchmark is at 7 gigs a second, ask them what they're copying. AI coding tools are fast. The problem is the overhead they create. I still end up testing different models, weighing answers, and turning scattered output into a plan myself. Verdant is the first tool I've used that manages the workflow around the code, not just the code itself. Take multi-plan mode. Instead of picking one model and hoping it was the right call, Verdant has 3 leading models weigh in together. So I've got a .NET issue tracker I maintain, and I asked Verdant to plan out a new dashboard feature for me. Claude came back with a detailed production-ready approach that keeps the new stuff isolated and safe. Gemini went the other direction, more of a fast prototype that just modifies what's already there. Verdant takes both and gives me one consolidated plan that I can refine or just let it run. From there, I pick the model and effort level for implementation, and with the help of the right skill, ASP.NET Core in this case, we're off to the races. There's also a multi-mode code review built in. Verdant's own benchmarks have it beating Codex Connector on precision and recall using 40% less tokens. And at any point, I can pop into VS Code to keep an eye on things, because I've still got some control issues I'm working through. But I'm getting better. This one's for people who are already building with AI but are tired of managing the workflow around it. It's less about piling more AI and more about cutting the busy work AI creates in the first place. You can check out Verdant at the link in the description. Now back to the video. Now let's get into the dev tests. And I'm going to start with the ones where these machines are surprisingly close before we get to what they're not close at. Speedometer and Jetstream, the classic browser benchmarks. And as expected, these are close. The M5 already has a strong single-core CPU, and since these are all the same, pretty much the same core, and these tests are mostly single-threaded JavaScript work, the gap between the M5 and the M5 Max here is not that huge. 61.4 on the M5, 60.2 on the M5 Pro, and 61.7 on the M5 Max. And there's your Jetstream results too. Slightly more detailed, has a few more different workloads, and that could explain potentially the slight difference we see in the test results. But that is the point. Everyday browser responsiveness, web app snappiness, you're not going to feel a big difference between these machines. So this is for the dev testing perspective and the end user perspective. The M5 is fast, that is not where the money goes. So where does it start to matter? Let's add more cores to the equation. This is a Python Mandelbrot set computation at 16,000 pixels using all cores via multiprocessing. Pure number crunching. No I/O, no compiler complexity, just how fast can you use all your cores. Look at all those cores being used, and no matter what machine we're looking at, the cores are all going to be used. So obviously the machine with more cores is going to win. M5 29.4 seconds, M5 Pro 12.2 seconds. Big difference. And M5 Max 11.7, a little bit faster. But the Pro and the Max are nearly the same. Same 18-core CPU, just half a second apart. So right away my Max is looking at the Pro and wondering what exactly it's paying for. But the M5 at 10 cores is 2.5 times slower. For context, the M4 was 29 seconds too. So the M5 base is basically the same speed as last year for multi-core work. The improvement came from adding more cores to the Pro and the Max, not from making the same cores faster. Alright, so pure compute scales linearly with cores, but real builds involve compilers, linkers, I/O, and memory pressure. Does the gap hold? In comes Xcode benchmark. 70 plus Cocoa pods, mixed Swift and Objective-C, C, and C++. This has kind of become the standard iOS dev build benchmark. M5, 154 seconds for this. By the way, the lower the better, obviously. It builds it faster. M5 Pro with 18 cores, 89 seconds for that one. And the M5 Max, 85 seconds. Well, here the M5 is nearly twice as slow as the Pro, but these two are pretty close. And here's a fun fact. The base M5 at 154 seconds is actually slower than the 3-year-old M2 Max, which did this in 127 seconds. More cores beat a faster clock every time. Now I should note, my M5 Pro is the full 18-core model. Max Tech tested the 15-core M5 Pro and got 99 seconds. And Max's M5 Max, wow, I just said Max so many times. They got roughly the same as mine. So even within the Pro tier, those 3 missing cores cost you about 10 seconds in this particular build. Something to keep in mind when configuring. But there's another story hiding in this chart. First time I ran this, I ran it immediately after a long WebKit build, which I'll go into in a moment, when the machines were still hot. Bad, Alex. Bad. But it was interesting because the M5 has only one fan, and with its single fan and no high power mode, it went from 154 seconds cold to 246 seconds hot. That's 60% slower, just from thermals. The M5 Pro lost 37%, and the M5 Max barely moved. And remember when I said keep the power modes in mind? This is why. The M5 doesn't just have fewer cores, it can't sustain what it has. But Xcode Benchmark is a medium-sized project. What happens when we throw something truly massive at these machines? A full, clean WebKit release build. Millions of lines of C++, hundreds of compilation units. M5 Max, 15.3 minutes. That's probably the fastest I've ever seen this test done. M5 Pro, 16.1 minutes. Less than a minute apart. Again, I'm starting to see a pattern here that my wallet doesn't love. Now, M5, 56.5 minutes. That's almost an hour versus 15 minutes, 3.7 times slower. This is the single most dramatic result in this entire comparison. If you compile large projects regularly, the base M5 is not in the same league. The 10 cores, the single fan, the thermal constraints, they all compound over a sustained build like this. Okay, but not everybody builds WebKit. What about the web developers in the audience? That's what I do, actually. Victor Sofkin, one of the founders of NX, created this large Monorepo test, which I like to use sometimes. It's pretty cool. This is a 253 package TypeScript Monorepo with over 5,000 files. And here's where things get a little bit uncomfortable again for M5 Max owners like me. Non-batch cold builds, M5 took 48 seconds, M5 Max took 42. That's a 15% difference. Not huge considering the price difference between these two. And in batch mode, basically identical across all three, about 13 seconds each. TypeScript compilation, transpilation is mostly single-threaded. It doesn't scale with core counts like C++ does. If you're a web dev working with TypeScript and Node, the base M5 is really fine. And that's an uncomfortable thought when you spend 3 times as much on the Max. Let's try another ecosystem and we'll see why memory matters. 100,000 generated C# classes and namespaces. This test is interesting because the previous M4 results showed a 25-second gap just from doubling the RAM, 16 gigs versus 32 gigs, with the same CPU. So it's not just about cores. M5 was 16 gigs, 84 seconds for this build. M5 Pro with 64 gigs, 55 seconds. And M5 Max with 128 gigs, 51 seconds. Obviously, core count is the primary driver here, 84 versus 51 seconds. But the Pro is only 4 seconds slower than the Max, despite having the same cores. That is memory bandwidth showing up in the build test, but just barely. 4 seconds, just a few $1,000s more. I keep writing these numbers down and feeling worse about my choices. Now the M5 at 16 gigs, faster than last year's M4 Air at 94 seconds, is still firmly in last place among the M5 family. So the Pro and the Max have been basically tied this entire time, but there's a whole other dimension to test. And this is where the Max finally gets to justify its existence. Maybe. Let's see. Before I run any AI models, I want to show you something, because local LLM performance depends on exactly 2 things, and we can measure them both directly. The first is memory bandwidth, and that's what I'm doing right now. Boom. Ooh. That's how fast the machine can read data from memory. This directly determines the token generation speed, tokens per second, because for every single token the model generates, it has to read the entire model's weights from memory. Stream Triad, the gold standard for practical memory bandwidth, and has been around for years. M5, 115 gigabytes per second, M5 Pro, 251, and M5 Max, 350. Now, Apple's spec sheet says 153, 307, and 614. Our measured numbers are lower, and that's normal. Every vendor spec is a theoretical ceiling, but the ratios still hold, roughly 1x, 2.1x, and 3x. Remember that ratio because we're about to see it again. This is the same MLX framework that runs local AI models doing matrix multiplications on the GPU. M5 got 8.9 teraflops, M5 Pro 19.7, and M5 Max 42.4. At bfloat 16, 15, 30, and 57 teraflops. That's almost perfect scaling with GPU core counts 10, 20, and 40. Yes, the GPU core counts. We haven't talked about that yet. This is where they come out to play. Now for the M5 Max, Apple says 614 gigabytes per second and 40 GPU cores. But what can it actually sustain? Now we know. So while bandwidth scales 1 to 2.2 to 3, compute scales from 1 to 2 to 4. Let's take a look to see if the AI performance matches. Llama 4 E4B. Yeah, it's new. So what? MLX can run it. Oh, MLX is the framework that runs LLMs on Apple Silicon. It's optimized. It's kind of like llama.cpp, but optimized for Apple Silicon. This is an 8.2 gigabyte model. Fits on all 3 machines. Token generation on M5 at 25 tokens per second, M5 Pro at 51, and M5 Max 87. Whew. There's a difference. That's 1x, 2.1x, and 3.5x. The bandwidth ratio is almost exactly right. The raw hardware benchmarks we just ran directly predict real AI performance. And finally, we can say that the Max is meaningfully faster than the Pro here. Not 4 seconds faster, not half a second faster, 70% faster. This is what bandwidth buys you. After spending all this time watching the Pro keeping up, this is the first test where I don't feel completely stupid for buying the Max. Now, all 3 machines can run this model, but the experience is different. 1, 2, 3. Just for kicks, I ran Llama 4 in LM Studio, so I have a comparison point with some of the ones I've been testing. 47 tokens per second on the M5, 98 tokens per second on the M5 Pro, and 166 on the M5 Max. But what happens when we step up to a bigger model? Qwen 3.527B at 4-bit quantization, 15 gigabytes. The M5 Pro runs it at 17.6 tokens per second, the M5 Max at 25.1, both usable. The M5, it crashed. A 15 gigabyte model on a machine with 16 gigabytes of total memory, there's nothing left for the operating system. It's not slow, it's broken. This is the memory wall. It's not about speed anymore, it's about whether the model fits at all. And then there's this, Qwen 3.5 122B, and Mixture of Experts model at 65 gigabytes. The M5 Pro maxes out at 64 gigabytes of RAM, and this model is 65 gigs before the OS even loads. It literally cannot exist on this machine. The M5 Max with 128 gigs, loads it fine, generates at 23 tokens per second. And here's the wild part. That's almost the same speed as the dense 27 billion parameter model, because only 10 billion parameters are active per token. Mixture of expert models, or MOE, like this 122 billion parameter model, give you a much smarter model at the same inference speed. But only if you have memory to hold it. This is the why you buy the Max demo. Not because it's a little faster, because entire categories of models simply don't exist in any other machine. Okay, I feel slightly less stupid now. So, do you remember how the M5 throttled 60% on compilation after getting hot? Well, I ran 20 back-to-back AI completions to see if the same thing happens during inference. And the M5 gets 22.8 tokens per second, plus or minus, and that's first to last run. The M5 Pro, 48.4 tokens per second, plus or minus, and the M5 Max, 82.4 tokens per second, plus or minus. All 3 are perfectly flat. There's no throttling on any of these machines, including the single-fan M5. Why, you might ask? Well, because LLM inference in this case is memory bandwidth bound. The tests I'm doing are not compute bound. It doesn't push the CPU or GPU hard enough to generate the kind of heat that causes throttling. Whereas compilation that we did earlier, it hammers all the cores at maximum power for minutes. Inference just reads from memory. So the thermal story is workload dependent. The M5 throttles on builds, it doesn't throttle on AI, and that's a nuance that a lot of reviews miss. So for browsing, writing code, TypeScript build, general productivity, the base M5 is embarrassingly close to both. It genuinely makes me question every dollar I spent on the Max. At one point when these came out in October, I considered switching from the M4 Max to using just this, and then doing heavier workloads on my Mac Studios, like video editing and AI. For Xcode builds, large compilations, anything that hits the cores with more than just a few minutes, the M5 falls off a cliff a little bit though, as we've seen. But the Pro handles all of that as well as the Max. For local AI though, that's where the lineup finally makes sense for a 3-tier product. The M5 can run small models, the M5 Pro can run serious ones, and the M5 Max can run models that literally don't fit anywhere else and do it really fast. But the M5 Pro is the real developer sweet spot. Professional iOS and macOS developers, full stack developers with Docker heavy workflows, and serious AI enthusiasts who want to run 70 billion parameter models. Really? Quantized, okay? So the M5 Pro is the one that makes me feel the most stupid because it does almost everything the Max does for significantly less money. Honestly, I think most people that are software developers that are professionals should just buy the M5 Pro and not feel bad about it. I'm the one that's an idiot that bought all these MacBooks, so I should feel bad. Anyway, if you wanted my first look at the M5 Max, a little bit of a deep dive, check out this video right here. Thanks for watching and I'll see you next time.